Greetings. This video is about energy, conservation of energy at the skate park, and today we're going to get some help on part C, so if you could please make your way to page 5 in the handout. Alright, here we are at page 5. Okay, so our objectives, building, explaining, and justifying equations for total energy, drawing graphical models, and writing equations. So that's what's going to happen here at the bottom. Okay, looking at activity number 1. So it wants the relationship between the total energy at A and the total energy at C. So let's get some symbols down here. So if we let these symbols, so for example, E tot A equals the total energy at A, and then the equivalent for position C, just make these into an equation that states the correct relationship. Don't overthink it. Okay, number 2. The total energy is made up of the different kinds of energy that are listed here. So then you need to make an equation here that relates the total energy to these types of energy. So what math would need to happen involving kinetic, potential, and thermal in order to end up with the total? So if you need a little refresher, we looked at this on part B, number 2, on page 2. So that'll give you some help there. Okay, number 3. Down here, we're going to expand for 2 different positions. Okay, so position A, they want the expanded total energy in terms of the kinetic, potential, and thermal for position A. So I'll do A for you. So what they're looking for is the energy, the total energy at A is equal to the kinetic at A plus the potential at A plus the thermal energy at A. Notice I'm using subscripts to denote that these energies are at a particular position. So for letter C, you do something similar, and then this final part, you want to think about what you put for number 1, but you want to expand. And this is an example of an expanded equation. So you're going to rewrite what you put for number 1, but you're going to expand. Okay, flipping over to page number 6. Okay, this is going to be drawing some diagrams here. Okay, for example, you may need to refer to the electronic handout that I gave you so you can see the colors better. I color-coded mine. My kinetic is green, potential is blue, thermal is orange. In this particular example, when we have a pendulum that's swinging, when it's at its highest point, all the energy is potential. So we can see that in our pie chart. Okay, for the equation part, we start out considering all the forms of energy. So the total energy at the highest point is the sum of the 3 energy types. Then we want to think about which ones are 0. Now in this graph that we're seeing, it's all potential. So that means it's not moving at its highest point, and apparently we don't have any thermal energy. So I'm going to assume that this is at its first swing. So then the total energy at the high point is all potential. So we would just shorten the equation to show that. So this is the equation of total energy at a certain point, and in this one it's the high point. Okay, some tips on the other 2. Okay, so let's take a look at this next one. The pendulum is at its lowest point. So to help out, I'm going to have you make some assumptions here. So let's assume that its lowest point is 0 height, and let's include air resistance here. So the pendulum has swung through air. So when you build these equations and do your graphic model, pie chart or bar graph, please include air resistance, and that's going to be reflected in the thermal energy part. Okay, and down here with the soccer ball being kicked, again, let's make some assumptions to help you get started here. So the soccer ball goes from position A to position B by being kicked. So at position A, let's assume